Hello, and welcome once again to Mr. Ansmira's wonderful world of C++. This is a program. Cut. This is a video that's going to show you a program. It's going to talk about the rectangle struct that you just did last week. In addition to the circle struct, I'm going to focus on the rectangle struct because why not? And I'm going to show you how this relates to what we're doing this week. How can you modify a struct into a class? What are the concepts? What will you do? Now, some of this is going to skip ahead a little bit and do some things that you might not have learned yet. But I just wanted to show you the process and the thought process of why you would make this a class rather than a struct. For example, if I come down here, I have, and this is a program I wrote. If you have your own, you can just copy yours into a file and you can modify yours with me, provided, of course, that you did it correctly. So here we have a struct called rectangle. It has double length, double width. Simple. Two functions. Perimeter takes a rectangle, returns a double. Area takes a rectangle, returns a double. Proper, very proper. We have rectangle R1. Perfect. R1 width set to some number, R1 length set to some number, and then we have the output statements. The rectangle's perimeter is, and then there's the function sending in the rectangle. There's the other output. There's the function sending in the rectangle, returning the area. Down here with my actual functions, we have the name of the function is area or perimeter. You're sending in the rectangle, give it a generic name like R, and return a double. So return the length times width. Return the 2L plus 2W formula, gives you the perimeter. So there's our struct. Now, what's wrong with it? Well, what's wrong with it would be, what if I do stupid things like this? I'm going to do negative 4.2 and 0. Let me run that. Because the computer doesn't know diddly squat about a rectangle. It has no idea what a rectangle is. This is only something that makes sense to human beings. A computer does not understand that a perimeter cannot be negative 8.4. The computer does not understand that an area can't be negative 0. And what in the world's at negative 0? That clearly makes no sense. And so, this, boys and girls, ladies and gentlemen, children of all ages, this is why we create classes. Because when I come up here and I change this into class rectangle, these values are now private. And look at this. This is vomiting errors. Inaccessible, inaccessible. Oh my gosh. All kinds of inaccessible. You can't do this anymore. You can't directly access the variable. You have to go through security to do this. And now, what's security? Well, we're getting a little ahead of ourselves. Let's go back up here. So in a class, the key concept of a class versus a struct. In a struct, we make everything wide open. We refer to that as public. So in a struct, everything is public. In a class, we have the opposite. Everything is private. But there are keywords, public and private, which we can differ and say, oh, we can make this public and this private. So the general rule of thumb for classes is that you make your variables private. So I'm going to put keyword private up here with the colon after it. Now, it is private by default, but we put it there just for completion's sake. So you make your variables private. You can't just access that. Think of a bank. You can't just walk into a bank. They have the bank vault wide open and, hey, I'm just going to, don't mind me, I'm just going to withdraw $1,000 here if you don't mind. And the guy's like, all right, sounds good. Of course they have security. They have tellers. They have computer systems in place that say, like, how much money you have, what's your account number, security in place to make sure that you don't just take money without having any sort of trust. Of course, in a world where everybody's honest and everybody's trustworthy, you don't need this. But welcome to the world, and welcome to human behavior. Of course you have to make things private. You have to have security here. So by making this private, we now will make public functions. So we make private variables public functions. Now, what functions should we make? Well, those two functions we already have down there, I want to make functions of the object because it's the rectangle's perimeter, apostrophe S. the rectangles area. So I'm going to move these two up here. Now, it's going to give you some, not an error, but it's going to give you the green line, meaning like you haven't made that yet. Well, that's kind of weird because like down here I did make it. We'll talk about that in a second. So what other changes are we going to make? We have private variables and then public functions. Well, one change we're going to make is if we're inside the rectangle, inside the braces, I am no longer going to send in the type rectangle. It would be like me walking up to you and wanting to know your birthday. If I ask you, what's your birthday? You don't turn to somebody else and say, hey, what's my birthday? Like, you know your birthday. A rectangle can figure out its own perimeter. A rectangle can figure out its own area. If you make it as part of the class, you don't need to add it in as a separate piece. So functions of a class don't take parameters necessarily of themselves. They just say, oh, just return this because I'm going to tell you. I already know the answer. I'm going to tell you. The other thing we have is we need to have a way to set these values. We need to have a way to set the width and the length. But they're private. So how can we possibly do that? Well, we make what's called a set function. A set function. It's public. So the way through to the private information is through a public interface. Again, using my bank analogy. In order for you to withdraw your money in a trustworthy, proper fashion, you've got to go up to the teller. The teller is public. It's the interface that you interact with when you want to withdraw or deposit money. So they do all the safeguard checking. If you are trying to get into a bar, trying to get into a club, trying to get a casino, there's a bouncer at the door. They check your ID. Are you over 18? Are you over 21? If you're trying to rent a car, fill out this information. You can't just drive a car off the lot. So we have these things in place in society. We need them in our programs. Now, again, we're going to fast forward a little bit. We'll talk about some of these things over the course of our live lessons, but I'm just going to keep it really simple for right now. I'm going to say void. I'm going to just call it set rectangle. And it's going to take two integers. It's going to take in the length and the width. Now, eventually, that's going to be a little bit different. But again, for right now, our purposes for this program, it's A-OK. All right. So I'm going to come down here into my main function. And we still have this problem where we can't set those. We're going to use the public function to get to the private data. So ultimately, I'm going to have this. I'm going to say r1.setRectangle 4.2, 8.5. So do the set rectangle action, behavior, verb of R1. Set the rectangle's information. This is public, so we can access it. We haven't coded it yet, but we can access it. And you'll see how we access it here momentarily. Down here, we don't say perimeter R1 anymore. Perimeter and area are now part of the class. So we say R1 dot perimeter. Almost like we're saying, hey, R1, what's your perimeter? Hey, R1, what's your area? So the dot, remember, acts like an apostrophe S. R1's perimeter. Now, notice they're functions. They're not variables. We want the basic building blocks to be the only variables here. Otherwise, you're wasting memory. A rectangle doesn't need to store the perimeter area. It can calculate it. So at the most basic level, a rectangle is just a length and a width. Okay, just like your birthday. You know your birthday's month, day, and year. If I were to ask you, how many days old are you? That's hopefully, unless you're a little bit off, you probably don't know that number off the top of your head. But you can calculate it based off of your birthday and another piece of information. So this is the same thing. Like things that can be calculated from the base information, we make functions. We don't make variables out of that. Okay, so for the main function, that's all that we do. We make that one change. Instead of using a variable, we use a function. Public functions allow you to access private data. They're the interface, they're the go-between between the user and the data that we want to make sure is accurate. Okay, so let's come down here to our function, then we'll do our third function, the set rectangle, here in a moment. So what do we change? How do we do this? Well, first we get rid of the parameter. And then when something is a function of a class, what we say is the name of the class, colon, colon. And then, you know, since I already had this, let me just show you what pops up. Rectangle, colon, colon, look what pops up. Area, length, perimeter, set rectangle. I don't know how easy it is to tell on the Zoom, so I'll let you look at it on your own computer, but there's icons next to each of these. The little like rectangular prism blue thing has a little padlock to its lower right. The length and width are the private variables. The padlock means they're private. The little blue thing means they're variables. The purple cube, there's no padlock there, it's public, and it's a function. Area, perimeter, and set rectangle are functions. So those icons can help you out with that. So now that area is inside rectangle, so to speak, you can access whatever you want. It's like when you get into the club, you can dance, have fun, you got past security. So you can access length and width with no issues because you're trusted. Area is a trusted function of rectangle. It knows that you're not going to mess anything up. Down here, we're going to do the same thing. Rectangle, colon, colon, perimeter. No parameters in there. Return 2 times the length, not r dot, but just the length, plus 2 times the width. Again, perimeter is a trusted function of rectangle, so it can directly access the variables inside of it, length and width. And that's the key to doing the set rectangle function. If you can directly access these private variables so long as you're within a function of the class, well, void rectangle, colon, colon, set rectangle, int len, int wid. So here's the thing. This is a set function. You're trying to set the variables of the class, the properties, the attributes. Len and wid are pieces of information that you're testing out. If you were to just type this, length equals len, width equals wid, you've lost the point. That's the right code so long as those are trustworthy numbers. But the whole point of what we're doing is to make sure those two variables are proper. Meaning, are they positive numbers? Not zero, not negative. Are they positive numbers? So I'm going to incorporate an if statement. I'm going to say if len is greater than 0, then I can set that. If wid is greater than 0, then I can set that. So that's if you pass security. That means, all right, you are good to go. What if you're not? Well, if you're not, you got to deal with it. Right? Just, a bouncer is going to throw you out of the club. So right here, let's do an else. See out invalid length, something like that, which is not just good enough, but now provide a value. What would be a good default length? How about if we do like length equals 1? And this is one of the things, like, you're designer of the program. You pick. Because some values make sense. Like, you wouldn't want to make it 0, 0 per se, because 0 is not a possible length or width. So you probably don't want to do 0 for length if it's a mistake. If you're doing a fraction, you don't want to make the denominator 0 because you're dividing by 0. Can't have a denominator 0. That's bad. So again, like, I'm just picking. I'm just like, all right, I'm just going to say, if you mess it up, I'm just going to make it 1 and just move on with my life. And of course, let me just make this a little bit shorter. No, I do have 2 lines there, so I need that. Actually, you know what? Let me not, because I'm not going to even chance messing this up. So then, same thing here. We're going to say else, and I'm going to just steal this, copy that, down here, invalid width. Width equals 1. So here's the difficulty in teaching classes. I mean, like computer programming class. We just did what, like 60 lines almost of just like, ooh, it's the area, like, area and perimeter of a rectangle, whoop-de-doo. So if I run this, this is a program you probably could have done like the first month of the first year course. And I just realized I used integers instead of doubles. Well, that was silly. You're probably sitting there at home screaming at the screen saying, Mr. Ensminger, you screwed up. You put in integers and not doubles. Yeah, I know. Well, my bad. Nobody's perfect. There we go. Okay, so why did we do all that? Like, it's so long for something that's so easy. Well, again, like everything we've done to this point, we've always just trusted the input. But what we have now is if I try to do this, if I try and put in invalid numbers, this is why our code's so big, because I want this to happen. I want it to say, like, no, these are wrong numbers, and now this is not something to be trusted. And, as we go through here, we'll learn better ways to do it other than, like, to print it and then say, like, just set it to some willy-nilly number like 1. But for right now, it's good enough. You get, hopefully, the concept and why we're doing this. It's not just to do perimeter. It's not just to do area. The whole point of this is more so, can you protect it from giving you invalid things? So we will obviously spend a great deal of time on this over the next couple of weeks. So I would prefer you, if you don't get something now, to ask, because it's only going to compound itself as we go. All right. Take care. Thanks for watching. Have a wonderful day, or night, or whenever this is.